The positive charges and negative charges are present, wherein the electric field direction is from positive to negative. Electric current is said to be a scalar quantity. Valence electrons are the electrons which resides on the outermost shell of an atom. The free electrons are free to move only during the absence of electrons. Hello everyone, I am Brinda, Faculty of Physics from Vidhyaashram Pre-University College, Mysuru, welcoming you all to session 1 of chapter 3. Chapter name is Current Electricity. So this chapter has the weightage of 13 marks, and here you get the questions like 1 mark questions, 2 mark questions, 5 mark long answers as well as 5 marks problems. So this is how you get the questions, and the total weightage of this chapter, Current Electricity, is for 13 marks. So this is known as a master chapter, wherein the most of the weightage is from this chapter. So I want each one of you to concentrate and listen to the class so that 13 marks will be in your pockets, and it will be very easy for you to score that 13 marks from this master chapter. Let us begin with the chapter. So the chapter name is Current Electricity. So current and electricity, you have two concepts over here. So what exactly is this current and electricity? Current and electricity, if both are one and the same, why two names at a time we have got? That would be a question. So now students, current and electricity both are different, that is why it is together. So what is meant by current? Current means it is a flow of charges. Okay, what flow of charges is responsible? That is, which charges is responsible for the current? That is electrons. And what is electricity? Current is nothing but it is due to the flow of charges, whereas electricity is nothing but the energy liberated due to that flow of charge is nothing but the electricity. So the term we have got current electricity. Okay, you know there are two charges, that is, one is positive charge as well as another one is negative charge. So these two charges are present over there, wherein the electrons are the one which are responsible for the electric current to flow. That is, the electric current and the flow of electrons both are opposite to each other. Why is that? Suppose if there is a circuit, here it is a positive, this is a battery symbol, that is, one is long and one is shorter line which is parallel to each other, represents the battery. Okay, so call it as B. This is positive and this is negative. It is connected to a circuit where you have a bulb, and then it is connected to the negative of the terminal, battery negative terminal. Clear? So this is a circuit connection, wherein there is a presence of a component as well as a battery connected to it. Okay, so you have a positive and negative connection to the bulb. Bulb representation is given in this manner. Clear? So now when the connection is done and when the switch is on, the circuit is said to be in on condition. That means there is a flow of electrons in this position. The electrons flow in this direction, and the electric field is in this direction. That is, I had discussed in the very first chapter, that is electric charges and fields, that is, the positive charges and negative charges are present, wherein the electric field direction is from positive to negative. Okay. Whereas when it comes to the flow of electrons, why the electrons are said to be in an opposite flow to that of the electric field? That is because there undergoes repulsion. The electrons undergo repulsion with this negative terminal, because of which there is an opposite flow of electrons, and one electron gains a little bit of energy and gets drifted, okay? And it passes its energy to the neighboring electron. Again, the neighboring electron gets drifted and it passes its energy to the neighboring electrons, and it goes on. Okay, this procedure continues until and unless it meets up the other terminal. That is why we call the flow of electrons are from negative terminal towards the positive, and it is in the direction to opposite to that of the electric field. That is the concept over here. Okay, so we have a diagram over here. So why have I taken this diagram? This is a natural source where we get the electric current. So this is a natural electricity which is generated. Clear? That is the lightning what we see. Fine. So the lightning takes from up to down. So it's from clouds towards the earth. Okay, that talks about the potential. So how is the flow of potential in this setup? It is like the flow of potential is always from higher potential to a lower potential. You can take even an example of this lightning as well as the sliding also. In the parks and all, the kids use slides. That is, they just climb the ladder, they sit on the top and they slide over till the lower position. So that is all about that. You can consider it as a potential examples, okay, from higher potential to a lower potential. Okay, so that is all about your introductory part of this current electricity. Now coming to the electric current. So how exactly is the current generated? I told you there is a movement of electrons. So what is electrons? Electrons are the charges. Okay, so what is electrons? Electrons are the charges, and it flows, and as well as we relate it along with the time. The flow of charges with respect to time we relate, so that we will get to know at certain area and at certain interval of time, when there is flow of charges, there exhibits the current. There is a presence of current, because the flow of charges itself is a current, but we measure it with the help of a time intervals. So what is electric current? Electric current is represented by I. So I is the alphabetical symbol for the current. So current is given as the charge flowing per unit time is said to be electric current I, which is given in ampere. Okay, which is given in ampere. So it is given as SI unit of current is said to be ampere, which is given in terms of A, called as AMPERE, ampere. Okay, so that is all about your electric current. Is electric current a vector quantity or a scalar quantity? Electric current is said to be a scalar quantity. That is because it has got certain value. There is certain magnitude there, but there is no presence of direction. It does not give any direction there, but it only gives the magnitude of what charge as well as what interval of time the charges are flowing. So that is said to be the current, and it obeys laws of scalar addition. That is all about your current. The domestic use of this electric current, it makes the use of either microampere range or in the milliampere range. That is the usage in case of the domestic appliances, whereas in a body also there is a presence of current. Okay, so that is how due to this neurons. Okay, you have got a receptors there, neurons, and which produces a bit of electricity. So a body also consists of something called as electric current. That is a natural generation of electric current which these neurons produces. The next thing is going on to electric current in conductors. So how exactly is the electric current studied in conductors? Suppose if in case you're taking solids, in case of solids, what is responsible to conduct electricity? That is nothing but valence electrons. So in case of conductors, valence electrons are very much necessary in order to conduct electricity. What is meant by a valence electrons? Valence electrons are the electrons which resides on the outermost shell within an atom. So that is all about the electric current in case of solid. Suppose you consider electric current in case of liquid. So in case of liquid, suppose if you consider the example as the electrolytic solution. So this electrolytic solution, where exactly you use? You use in your domestic cases also, and that is nothing but your inverters. At your home you have got your inverters. Those inverters, sometimes it uses liquid electrolytic solution. So this liquid electrolytic solutions, which is the conducting particle in this liquid, and that is nothing but the positive and negative ions. So what is meant by ions? Ions are the atoms with a missing electron. So ions are the atoms with a missing electrons. Those atoms with a missing electron is known as ion. Okay, coming to next one, next state of matter, that is gas. In case of gas, for example, you can take it as a discharge tubes. In case of those gas conductors, what exactly acts as a conducting particle? That is nothing but positive ion and electrons, both acts as a conducting particles. So these are the conducting particles in case of three states of matter, in case of solid, liquid as well as gases. So the electric current in conductors, and which is how is the electric current produces? Because of these valence electron, positive and negative ions and electrons in case of gases. Coming to the next topic, that is free electrons. What is meant by a free electron? The name itself, it tells the electrons are free. In case of solids and all, the molecules are so very tightly packed. But the electrons within those molecules, that is the solids, tends to move. That means it is very free to move. These are called as free electrons. The free electrons are free to move only during the absence of electrons. When the field is applied, that is when the circuit is connected to the terminals of the battery, what happens to the free electrons? It tends to move in a one single direction. So, when suppose if this is a negative which is randomly moving in each and every positions, and this happens in case of absence of electric field. Okay, when the circuit is not connected to any of the source. When the circuit is connected to the source, that is nothing but the battery, what happens to the direction of the negative electrons? It moves in one single direction, presence of electric field. Okay, so when is it called as free electrons? When is the conductor is having a free electrons? That is only when during the absence of electric field. During the presence, it is not called as free electrons, but it moves in one single direction. And when there is absence of the source which is connected to the circuit, what happens? That is the electrons which are freely moving, it tends to have same magnitude and it moves in a random direction, and finally it has the ability to cancel out each other. That means though there is a presence of charges there, it cancels out each other's values, because of which we say there is no passage of the electric current. So the electric current flowing through a circuit which is not connected to the battery is said to be zero due to the cancelling effect. That is all about your free electrons in this chapter. Coming on to the Ohm's law. So having all these introductory concept of how exactly the electric current is present, how exactly the electrons are moving and on which way it's moving, having all these concepts in our account, let us just check into what is meant by Ohm's law. So who discovered this Ohm's law? It was given by Georg Siemens Ohm. Okay, so here what exactly is Ohm's law says? Ohm's law tells that the potential difference across the conductor, that is we have a conductor over here, which is a tube-like structure. Suppose this object is a conductor which is having certain length, call it as L, and current I is flowing through the conductor. When the current is flowing, there is a potential difference across two ends of the conductor. Correct? So, that across the ends of the conductor, that potential difference is given by V. Call V as the potential difference across the at the ends of the conductor. So, when that is the case, we have the potential difference which is applied across the conductor is directly proportional to the current which is flowing through the conductor. The potential which is given in terms of V, potential difference which is applied to the conductor is directly proportional to the current which is flowing through the conductor, which can be given as, on removing the proportionality constant, we have V is equal to R into I, where V is potential difference, I is said to be the current, and R is nothing but the constant called as resistance. R is said to be called as resistance. Okay, so this is all about Ohm's law, and it is one of the important questions in the exam point of view. So you will have to know what is meant by Ohm's law, state Ohm's law. So Ohm's law is nothing but, instead of by hearting this definition, you can just have a visual concept of this diagram, and you can explain so very well that it is potential difference which is applied across the ends is directly proportional to the current. Removing the proportionality, you have got your R, and what is R? It is resistance. So that is all about your Ohm's law. So now coming on to resistance. What is resistance? Resistance means there is a resistivity, that is resistance. A component is having certain resistance in the sense it is applying certain force, that is opposing force. Resistance means it is called as a opposing force. Okay, it resists itself from any other objects coming to it or any other things that is coming to it. So that is all about your resistance. So how do you define this resistance? Resistance, according to the first law, it is given as resistance is directly proportional to the length. As the length of the conductor increases, its power of opposing also increases. As the length of the conductor increases, the resistivity also increases, is the one which is told in the very first law of resistance, called as resistance is directly proportional to the length. Coming to the second law of resistance, it tells that resistance is inversely proportional to the area. That means as the area increases, the power of resistance decreases, or as the area decreases, the power of resistance increases. So these are the concepts which you will have to keep in your mind. It is very, very important even for the practical of your second PUC. Okay, so it is that you have to remember Ohm's law as well as how is the resistance applied and on what factor it depends. So now on combining these two equations of resistance, we have resistance is directly proportional to length and inversely proportional to area, and on removing the proportionality constant, you have got a constant called as rho into L by A. So this is called as rho, R-H-O. So rho is the pronunciation. So what is that rho? Rho is nothing but the resistivity. It is resistivity. So resistance is having a power called as resistivity. So how much is the resistivity of a certain conductor can be checked by using this formula. So what is resistance? Resistance is nothing but, if suppose you take your I here, you can just tell it's a ratio of potential difference across the ends of the conductor and the current flowing through it can be the resistance, and this is how you give the formula of resistance. Resistance R is equal to rho into L by A. Okay. So now on what factors does this resistance depend? It depends on the length, it depends on the area, which tells that it depends on the dimensions of the conductor. and it depends upon the material, which material we use, as well as the temperature. It is temperature dependent, material dependent, as well as dimension dependent. So these are the resistance depend on these many things. So what do we call it as? R resistance is equal to rho into L divided by A, which is the equation for resistance. By looking at this itself, we can say it depends on the dimensions, that is L by A. It depends on the material and temperature. So what is the SI unit of resistance? And the SI unit of resistance is said to be ohm, which is called as OHM. Okay, this was called after the scientist who discovered Ohm's law. Okay, so it is called as ohm. Clear? So now, after finding out this SI unit, we will have to define what is meant by 1 ohm. Okay, so define 1 ohm. If this is your question, 1 ohm. What is 1 ohm? Ohm means it is a resistance. So we have to define when will the resistance R be 1. So it can be 1 when one number divides the other number which are of same value, or 1 divided by 1 gives you 1. So this is just a rough work wherein I have to understand when can you call resistance as 1 ohm. So define 1 ohm. 1 ohm is defined as by having a formula R is equal to V divided by I. Okay, so having this formula, I can just give out, using this I can give out the definition as define 1 ohm. A conductor is said to have 1 ohm when 1 ampere of current is flowing through a conductor and which has the potential difference of 1 volt across its ends. That is nothing but your defining of 1 ohm. So what is 1 ohm? When can a conductor have resistance of 1 ohm? That is when voltage is 1 as well as current is 1. So define 1 ohm. 1 ohm means it is the conductor is said to have a resistance of 1 ohm when 1 ampere of current is flowing through a conductor which has the potential difference of 1 volt across its end. That is all about your definition for 1 ohm. So we have studied regarding current, electricity, how exactly the difference occurs in current as well as electricity. Chapter's name, what is meant by electric current and which are the charges responsible for it, and how is the flow of charges as well as that of the electric field. What is called as free charge, how exactly it acts in solid, liquid as well as gas forms, and here we have the resistance, how exactly this resistance occurred, and how do you define 1 ohm and what is meant by Ohm's law. These are the concepts we have studied till now. And next, coming to current density. What is a current density? Current density is defined as, and it is given by J and vector form, it is defined as electric current per unit area. So electric current which is produced per unit area is nothing but the current density, whose SI unit is said to be, current is given by A, ampere, area is length into breadth, so it can be meter into meter, so it can be meter square, so it's divided by meter square, or it can also be written as A inverse. So this is the SI unit of current density which is given by the help of a J. Let us check the combination of current density as well as the electric field. Here we have the electric field given by, suppose if you consider a conductor which is having a length L and the voltage across it is V and the current flowing through it is I, we have electric field E is equal to voltage per unit length. E is equal to V by L. And what is that V? V is nothing but V is equal to R into I. It is also called as IR. So here I and substitute for R, that is the previous equation, that is rho into L by A. Resistance value is rho into L by A is the equation of this. Substitute the same equation on equation 1. Suppose this is equation 1 and this is said to be equation 2. Substituting equation 2 in case of V in equation 1, you have E is equal to, what is V? It is rho into I divided by A into L divided by L. So L and L gets cancelled and I into A is nothing but your current density. It is J vector. So since it is J vector, now you have electric field E is equal to rho into J vector. So now getting your resistivity towards down, that is 1 by rho into vector E is equal to J current density. 1 by rho, that is reciprocal of resistivity, is called as conductivity. Reciprocal of resistivity is conductivity, which is given in terms of sigma. Okay, when this is the case, you will have to write it as E is equal to J vector, which gives the conductivity, current density as well as the electric field is one single equation. That is all about your current density, how it is related to conductivity and electric field. So in today's class, we have studied about the introductory part, current, electricity, that means what is meant by electric current, how are the charges which flows, and what is meant by resistance, ohm, current density, how is it equated with conductivity, and what is meant by conductivity. So these are the concepts, that is the few concepts of the current electricity chapter. Let us all meet in the next class with the upcoming session of the same chapter. Until then, have a good day. Thank you.